Nice to see everybody here today, including one of my oldest friends in the United States back there. So it's a nice audience to be in front of. So what I've been showing here, just so you know, is I had to put together a presentation for a customer last fall, and I just took some video snippets that I'd recorded over the last year, or they'd gotten from folks like Phil here who works with me, and put them together just to kind of show and tell some of the broad diversity of things that is happening in 3D across ArcGIS, specifically relevant to some of the use cases that they were interested in. This is actually the fifth year in a row that I have done the 3D across ArcGIS talk here, and the diversity of what I can talk about has expanded so much in that time that I can't possibly cover and deep dive into everything relevant in an hour anymore. So we're going to even look at how we might break this up into a couple different talks next year. A couple quick questions before I dive in. So who has actually been in the 3D across ArcGIS talk here at the Dev Summit or EPC before? Okay, one. Come on, I know Jesse and Sylvia, you guys probably, yes, all right, not that many, great, okay, that's actually reassuring to me because of the pattern that I chose to do for today, so that's okay. Who is using 3D in ArcGIS today? All right, great, so that's good, so hopefully you'll know much of what we're going to talk about today, and we'll reserve some time for questions at the end. Who's used or using 3D in non-ArcGIS tools today? Okay, a few, all right, not that many, some, okay, that's good. All right, well, great. Actually, maybe one last question is, who's using 3D on the web? In mobile? Okay, all right, interesting. I assume the rest of you are mostly desktop users, so okay, cool. All right, great. So I'm Chris Andrews. I have a new title this year. I'm the group product manager for this focused products group that includes a lot of things that aren't just 3D anymore. But with me is Phil Milkey. Phil, you want to introduce yourself? Or?
Hi, well, I'm new to the role. I'm just starting to understand what being a product manager means, and in this case, it's the interrelationship of our 3D web user experience and how that ends up relating to things like Web App Builder, Operations Dashboard, and the JavaScript API, story maps, and there's a wide variety of things, and happy to be here.
Yeah, for sure. And I wouldn't be able to do my job today if Phil hadn't joined me last summer. So we're doing well and expanding quite a bit. Just for a little history, when I started here a little under 5 years ago, I was an individual contributor. Now I've got a team of like 10 PMs, and as you guys saw in the Dev Summit plenary this morning, for the first 90 seconds of that hello video, there were no 2D maps shown, right? So it was 3D point cloud, 3D this, 3D that, and then they got into some 2D maps. So what we're seeing is really fantastic ubiquitous growth of 3D across the platform, and that has supported my thesis since I joined Esri, which is it's not 3D, it's just modernized GIS. So hopefully that's what you're seeing as coming across. And you should be able to use 2D, 3D, 4D, whatever you want to solve the problems you need. And so, all right, with that, I'm going to jump in. Just a safe harbor statement. You don't see many of these at Esri. We actually should show more of them. But if we talk about future stuff, just be aware that future plans may change. And so you should be careful about making business decisions or partnering decisions based upon future plans. Okay. So today I'm going to cover some of the 3D products and things like scene layers and other parts of the platform. I'll talk a little bit about GIS and BIM integration. There's a deeper dive into the GIS and BIM story on Friday morning for those of you who are troopers and last till Friday morning. Then Phil is going to talk about 3D on the web, and then we'll both talk about some brief roadmap stuff. Like I said, there's so much diversity of what's happening across the platform these days that I can't possibly convey everything that we're doing in an hour, but hopefully we'll give you some information that's useful and then answer some questions and leave you a little bit more informed. Some of you may have seen this slide before. The reason for this drive into 3D and the reason for my initial existence at Esri a few years ago was because there are incredibly diverse, new, massive types of data sets being collected all around the world. And many of these new types of data or new versions of older types of data actually have a 3D component. One of the reasons for that is because 3D is we live in a 3D world, and 3D is a better, more accurate representation of the world around us. And I'll talk about that a little bit more in a sec. All of this data availability is driving the need for new experiences. I actually took a word out of this last night. It used to say data availability is driving demand for new GIS experiences. In fact, my first customers ever were realtors. They would kick you out of a sales call if you talked to them about GIS. The focus products group that I lead is largely about enabling users who don't care about GIS to have an improved workflow or life because of GIS. That has actually been a theme throughout my whole career, and it's interesting that I've ended up leading a team focused on that here at Esri, because Esri is the GIS company, right? We make ArcGIS. But Jack and others have realized deeply that to really make the biggest impact on the world around us, we need to think beyond the traditional desktop and GIS tools and workflows. And actually, so like I said, I took a word out of this last night. This data availability is driving the need for better spatially integrated experiences where the users may have no idea they're using GIS, right? Small things, but they definitely sometimes mean a big long-term impact. I do talk about 3D, and I'll continue to talk about 3D for a long time because, you know, my sister can understand what 3D is, and my 12-year-old son understands what 3D is. It has become a kind of a vernacular for many other aspects of user experience that people expect to see. Deep and immersive experiences, real-time, interactive, game-like, all these kinds of things. Well, all those things can be associated through 3D, and that's why I'll continue to talk about 3D. People sometimes ask me why not talk about 4D or ND or things like that, but then it starts to become a little bit too esoteric for larger audiences. There really are different values to working. The value prop for using 3D is slightly different from traditional 2D mapping. And part of that is the pattern of working with 3D information. In the old days with maps, you used to compile your map data, you used to layer it on top of each other, then you would build some processing model, you would execute the processing model, generate a report, and then you might actually make a pretty map to help convey information along with the report information that you generated, right? So that the actual pretty map was often a back-end product as part of the workflow, but often the primary value was actually non-mapping and text and numbers that you got out of an analysis. In 3D, you compile your information into this 3D scene, and then you've got this thing that could look like or is an approximation of the real world, and you explore it. So the 3D interface into your data actually becomes a primary step of interaction in that workflow. And then you might choose to do an analysis or generate reports later. So fundamentally, it's changed, the business value has driven different ways of interacting with geospatial data. And what we see is users ask us for 3D for more accurate representations of the real world. They use 3D to visualize stuff that doesn't exist or that they can't actually get to. 3D is definitely better for communicating with non-technical audiences. And then you can analyze behavior and aesthetics in 3D. You don't really analyze too much aesthetic information in 2D maps, right? So like what's brick in 2D, right? That's one of the things that I always talk about. All right. So my job has been for the last few years to focus on pushing out 3D across ArcGIS. We're not done. We'll never be done. The market continues to develop new technologies and techniques and data types that we'll still need to add to the kind of 2D, 3D GIS portfolio that we have. But a lot of my message has been, it's not an extension, it's not an add-on product, it's just GIS. It's modern GIS. And I'm really happy to see that taking hold, not just at Esri, but also at some of our competitors. Everything that we've done has been intended to be part of that web services-based architecture that is the core of the geospatial cloud, as Jack is talking about it now. We definitely have started to develop new clients and experiences. One of the ArcGIS Earth team is back there today, and she is there rolling out a new set of mobile apps this year so that we can have a production 3D mobile app. The JavaScript team has also rolled out mobile in the last couple of years. We're modernizing workflows, right? It should be essentially 1 or 2 clicks from that Revit model into the building scene layer that Joe demoed up on stage today. And we've pretty much made that happen. And there's always nuance, but that is pretty much what the workflow is today. Okay. Just to cover some terminology that you'll hear if you haven't been thinking about 3D much, but it sounds like a lot of you have. So web scenes are kind of like a container of layers and environment and some other behavior that you can use to transport a common aggregation of information throughout the ArcGIS platform, which is a lot like what a web map is. But at some point before I got to Esri, they made a distinction between 2D and 3D, and so we have web maps and we have web scenes. Web scenes and web maps aren't perfectly equivalent, but they're increasingly equivalent, and some of it is just generational. There's new stuff we're doing in web scenes that didn't exist in web maps, but web maps is a longer history, so there's a little bit more functionality there in some cases. Web scenes are essential for 3D apps on pretty much every platform and experience in Esri. Scene layers are these scalable caches of graphics, styles, and attributes. I can go on for a long time about scene layers. They're a critical enabling technology that we released in the last few years to make it possible to transport very large, like I'm talking about the largest ones I've seen have been over 1 terabyte in size, very large packages of 3D content, either across desktops, onto a device, or to be published into the cloud and then exposed as published web scenes. So it's important to know that the scene layer mechanism and this open spec we released around it is the key enabling tech that made that happen. Mobile scene packages, which are actually, I missed that last night. They actually are released, and you can now start to publish them from Pro and consume them in Runtime apps. Pretty soon you'll be able to consume them in Earth and then publish them to enterprise and online. Mobile scene packages are a way to wrap up an entire web scene and then transport that to somebody else's experience. For those of you who might be familiar with Google or Skyline, this is very much like the disconnected globe experience in Google, where you can cook out part of the globe, put it on a Marine's laptop or ICOP or now Android device and have them go out in the field without having a connection. This video is part of the opening slide video that I had going, and this is what you're seeing in the background here is an example of BIM data actually converted into one type of scene layer. So this airport, so this is Houston, George Bush Intercontinental. The airport was very nice and gave us all, I think it was 6 gigabytes of Revit content. And last summer, one of my colleagues translated that into 3D object scene layers. It would have not been possible to put 6 gigabytes of Revit content into a web experience in Esri before last summer, right? So we have been working on new capabilities. Actually, forget about in Esri, in any GIS experience like this, right? This is a WebGL zero client experience where, zero download experience, where I'm able to access gigs and gigs and gigs of content. If I wanted to, like we've got the base maps and the world terrain there. If I wanted to, I could have point cloud data. I could have other traditional 2D data, all in the same experience. So like I said earlier, our goal is to enable this new 3D capability through this Esri ArcGIS web services infrastructure that is the heart of the geospatial cloud. We have things like the scene viewer that Phil's going to talk about. We have the ArcGIS API for JavaScript. Phil's going to talk about that too. We have the ArcGIS Runtime 3D capabilities as well. We have tried very hard to push out 3D capability throughout the platform. And there are some nuances of what works where. For example, vector tiles, which they made a big deal about today, don't work in the 3D runtime experiences yet. The plan is to make that happen, but just be aware occasionally there is nuance because it's hard to push out all that capability all around the platform. The 3D team is deeply committed to enabling customers through open standards. We released this thing, I3S, which is the specification for scene layers, into OGC, and it was adopted as a community standard. We actually just updated the spec last week, and we've even added our new point cloud spec and the building scene layer spec into it. We even have things like, does anybody in here care about CityGML? Nobody? Okay, not too many people in here. We're actually rolling out a CityGML to I3S mechanism pretty soon as well. We've seen really good third-party adoption of I3S. Safe Software, Vicon, Pix4D, a bunch of other partners are actually starting to export data and work with I3S content. I think that's enough of the spec for the moment. You guys know about ArcGIS Pro, I hope. If you sat through any of the plenaries, you are familiar with ArcGIS Pro. Pro is our premier 2D and 3D desktop authoring experience, right? So for hard GIS jobs where I've got to package up a bunch of content or publish a bunch of content, manipulate it, it's Pro. If I'm going to do it in a massive distributed automated case, then there's some enterprise things that I'm going to do. But for many of your traditional GIS workflows, it's really Pro that is the workhorse. Scene Viewer is our out-of-the-box web experience for interacting with 3D content. Phil's going to demo or talk about this a little bit more, but the Scene Viewer it's like the Map Viewer. It's there, you can use it. You can also take the JavaScript API and customize your own kind of version of the Scene Viewer as well. Oops, I think I might have missed one. Nope, I didn't. Okay, ArcGIS Earth is now, it's a little over 3 years old. Earth is a lightweight geo-browser, globe-based application designed to be a lot like Skyline Globe or Google Earth. And we are continuing to work on it. They're rolling out another release, I think, in the next week or this week. And we are extending it to have mobile app versions of Earth as well. We still have plans to roll out an SDK for Earth, and we have lots of plans for where we're going to go with Earth in the future. The idea behind Earth was to actually put it on the desktop of someone who may not know that they were working with GIS. I have taught classes in 3rd grade and 5th grade with Earth, and I didn't need to talk about GIS to the kids. They basically ran the class themselves because they took a scavenger hunt that I built for them, and they went and just ran with it. And it was zero training, lots of fun, lots of active interaction. An elementary student, a cadet, a commander, a utilities inspector, all these kinds of folks should just be able to pick up Earth and know where they are on the planet and how to go explore their data. It's really lightweight. It's not intended to replace Pro workflows. We're not going to publish data out of it in like big giant scene packages or anything like that anytime soon. But it is intended to allow somebody who needs to have a map-centric experience as a desktop experience on a laptop or phone to explore GIS content in global projection systems, so GCS projection systems typically. Come on. All right. There are other apps that we'll talk about that actually do work with 3D. So we got Earth, and Drone to Map is a 3D app, and then there are web apps like Web App Builder. Story Maps work with 3D. The ArcGIS Companion app works with 3D. You can explore your 3D web scenes and web apps in the Companion app. And then, of course, I already mentioned ArcGIS Earth Mobile. I do expect in a few years for there to be a bunch more apps up here that are 3D. ArcGIS Indoors is a new product that's releasing this month. Has anybody heard of Indoors? Or not? Yes, all right, so lots of people have heard of Indoors, okay. Indoors is actually intended in the long run to be a resource management system for anything that is inside or around a building or a set of buildings. And built into Indoors is an expectation that you want to work with the data either in 2D or in 3D. So they are looking at down the road things like 3D collector-like workflows and other things like that. Today, you basically take CAD data, you munge it into a format that Indoors can read in GIS, and then you basically hydrate these different client experiences for navigation, location, calendar integration, and I think some lightweight asset inspection. And they definitely, they're just getting it out the door now, and there are a lot more plans for where they want to go with that. ArcGIS Urban is intended to be a complete focused system for zoning management and also for allowing cities to manage and visualize plans and projects and then share those with some of their stakeholders. I have deep roots with urban planning. I worked at Autodesk for 7 years, and my first 4 years there, I basically built what was intended to be an urban planning system that is now known as InfraWorks, which has actually been repositioned for preliminary design in the civil engineering space. But my first 2 and 3 years there were gathering requirements for and then building products specifically for urban planning. I think it's great that Esri has decided to go into this. We're releasing Urban later this year. Urban is one of the apps on my team. And it is intrinsically a 3D experience. The goal is to work with architects and other developers who typically work in 3D packages. Okay. Esri City Engine is still something that we maintain actively and we use as not only a sold product but also an R&D platform. City Engine has basically been repositioned as an advanced tool for urban planners and urban designers over the last few years. Has some fancy reporting capability. They're also embedding some of the new interactive analysis tools that we have. And then they've increasingly improved the platform integration of City Engine in the last couple of years. One of the fun things that the team, City Engine team did in the last year is to be the first group to embrace the Unreal Engine Datasmith workflow. We have increasingly gotten demands for working with game engines. Unreal Engine is, it's considered like the Cadillac game engine out there compared with Unity. And we actually have pretty good ties to both teams, Unity and Unreal. But the City Engine team decided to take advantage of a dedicated workflow that the Unreal team built for getting content out of one content creation system and into the game engine. And so they were actually the first adopter of the Datasmith pathway. And then one of the outcomes of that, I mentioned new experiences. One of the outcomes of that was that they now have a template that you can deploy to actually create a VR experience with City Engine. We also have this other ArcGIS 360 VR experience that was created before that. It's kind of like a bubble viewing experience where you can export bubbles from within a city model or model and port them to your phone and then look at them in a Samsung Gear VR. We will be exploring more VR, AR, mixed reality experiences over time. Right now, we're still kind of working at it at the core tech level, building out some simple examples like this, and then watching to see where the market goes as well, because there's a lot of heterogeneity and up and down in this market so far. The Zurich R&D team is the primary team that is doing a lot of the work around VR and these mixed reality experiences. One of the experiences that they do plan to release as part of Urban is essentially a tabletop mixed reality experience where you can look at the table in front of you through your headset and see the city model and the urban plans and projects that you're working with. Then if you want, you can even teleport yourself inside that model to actually be at the scale of the city model. And it's a multi-user experience so that you can actually collaborate and interact with other users looking at the same information. Okay, and this is just a little video that shows it. I think the template right now, this video I think is based on the template. The template right now, the original version of it, I believe just had this scene outside the Zurich R&D office. I think they've actually changed that now so that you can put your own scene around it if you want, or you can make the scene go away and just be looking at the room around you. But this is, it's where the folks who want it really want this badly. It doesn't fit all use cases for folks who want some kind of XR experience, but this is pretty popular in urban planning and some other planning use cases. We also have, just to reinforce, we have a lot of developer tools at Esri. 3D is intended to be in as many developer tools as we can get it into. Occasionally you run into issues where some GP tools or certain parts of like a Python extension or something don't process 3D the way you want. What I would say is please complain to us about that. Do you know that for minor complaints, only 1 in 24 people will actually call it into a tech company. That means that, you know, if you don't call it in, you've got to hope that 23 other people experience it and one of those people calls it in. So if you see something that you don't like, post it in GeoNet. email me at candrews@esri.com or otherwise route it into tech support, because this is one place where I think we really need to focus on making sure that we are 3D enabled everywhere, okay? All right, so I'm just going to talk briefly about our BIM story. The reason that so I've spent easily 50% of my time in the last 18 months, maybe more, talking about or working on our BIM story. The Autodesk Partnership actually started 3 years ago. I can definitively tell you that even if there are folks from Trimble in the room who we're working with, or other folks in AEC vendor companies who might be in the room, Autodesk so far has been the most compatible go-to-market story that I've seen with Esri for partnering in my career working around or with Esri, which has been since I got into the market back in 1997. So they've got a very compatible story. They've really gotten out of the geospatial space, and we are not in the BIM space, so it's a really friendly go-to-market. We understand that they don't address all of our issues and all issues in the BIM market, and we do have plans for addressing others, but it's why we end up talking about Autodesk so much. The reason that became important, it became important to introduce the Autodesk Partnership as an idea to Jack and folks about 3 years ago, was because the moment that I went out there and started talking about how 3D is just modern GIS, well, users came to us and said, yeah, duh, and you know what? Real world 3D is not Jello cubes and billboarded symbols, right? It is real world assets, right? Rail stations, airports, buildings, tunnels, embankment, redevelopments, all kinds of stuff, right? So, and I knew that as well coming in from Autodesk, so it just turned out to be the right time. Introduced the partnership, and that really has driven a lot of our effort around trying to satisfy BIM workflows. This is a slightly updated version of a slide that some people have said they're tired of looking at, but one of the things that I will say about this slide is we tried very hard at coming up with different models for how to illustrate the handoff between BIM and GIS. But what I really struggled with is, having been in the domain for a long time, is there is no handoff. GIS information is useful throughout the BIM process. So BIM, building information modeling, is a process for saving time and dollars during construction and design. That process is executed on by folks like HDR, who I guess there are 20, 25 of them here at this show, AECom, these big AEC services providers. They employ BIM because they know they're saving their customers money, and if they save their customers money, their customers are going to spend more money with them later, right? So, and the customers can get more done. So GIS data is useful throughout the BIM process. There is no handoff between BIM and GIS. Likewise, the promise of BIM is that you actually get potentially as-built model data for your assets that is usable then in life cycle maintenance of the buildings. There's a lot of nuance on that I can't get into in this talk, but I do some writing about it. I've got a pretty popular blog about it that I wrote about 4 weeks ago. If you come to the talk on Friday, I'll talk about that a fair bit more. One of the things about this slide that a lot of people have liked is that it shows that GIS and CAD or BIM are not on opposite sides and competitive. The first time that we had this up on a big 6-foot image at Autodesk University 2 years ago, there were people taking selfies with it because they were so surprised that we were presenting a view that wasn't competitive against Autodesk and the CAD world. And so this view of the world where life cycle stuff is happening all the time and the BIM process is happening all the time was really appealing to folks because it really showed them a better picture of how the world really works. It's a little too complicated for executive meetings, but actually I had a lot of executives last summer at the UC say, don't make this slide go away, because it is how they see the world working. So anyway, that's enough of that soapbox. With Esri and Autodesk working together, we are looking at kind of using BIM and GIS information appropriately at the right place for the right user at the right time at the right level of resolution throughout the whole design to operations workflow. And we are two companies. We have some roadmap alignment, but we also have different directions that we have to satisfy. Not everything that users want is going to happen at once, but we have had some really great things come out of it. They've built the connector for ArcGIS. in InfoWorks to view live data, and they're actually working on writing out from their civil products into GIS, which is pretty exciting for us and for their users. And then we've done things like introduce this new building scene layer that Joe talked about today to take data like that airport that I showed, and not only publish it out as just kind of like individual layers, but actually to encapsulate the whole building as an object in a scene layer, keeping the structure from inside the BIM model itself, and also keeping the attribution, and then possibly also adding on other behaviors such as filters. And so actually, I look at the building scene layer as more like an object data store for a building than I do as a traditional GIS layer. It's definitely not we're way beyond points, lines, and polygons at this point with this. So there's a lot more information in there and a lot more potential in what we've built than what we've had the time to expose so far. And hopefully we'll be able to do a lot more with it, and maybe even extend the concept to like a transportation scene layer in the future, or a road or a rail scene layer, something like that. With Autodesk and with other partners, we're really going to be focusing on higher value workflows in the future as well, moving away from just the point connections between BIM products and GIS products, or different data stores and other data stores. There are really three key areas where we want to focus moving forward with Autodesk in particular, and with other partners like Trimble. One is on having better patterns for capturing the real world around us. We're seeing increasing interest in capturing high-res textured meshes for large, say, central business districts around the world. Likewise for building interiors. And Esri doesn't really do that data capture. We rely on partners to do it. So we're going to be working with Autodesk and Trimble and others to try to streamline that flow of data from reality capture into GIS to be useful for you and your users. We are also looking at, so yes, we're releasing ArcGIS Urban. We also have City Engine. Both of those are for urban planning and urban designers. But we also get the immediate ask, can you use BIM information in those experiences? So one of the things that we will be doing is going to market around an integrated BIM and GIS story to support that planning and kind of pre-design evaluation workflow to support some of the more intensive AEC workflows. We're not going to go into BIM program management, right? There's Primavera, Procore, BIM 360, lots of stuff there. We hope to tie into those things at some point, or make GIS information more usable in those things. That's a different part of the BIM process than where we're going to play directly. And then finally, we get a lot of asks around kind of this 3D dashboard of my city or my campus or my whatever, my utility, my airport, port. And we are going to explore what that really means. It is probably not the same thing as the urban planning platform. It probably looks like something else that has dashboards and different ways of visualizing information, real-time information. That's something that we're just kind of kicking off some exploration around. If you have ideas on it, let us know. We'd certainly be, everything that we do is driven by user and customer input. So, okay, I'm going to switch to let Phil talk.
All right, thank you. Well, I thought it might be good for us to.
Sorry.
Oh yeah. Well, I'm going to be talking about some of the recent advances that we've made in 3D WebGIS, and I thought that there's really no better way to do this than to bring everything together into a story map here. So this is a cascade story map that's going to be going through a couple of our recent advances over the last year. And to begin with, one of the biggest improvements has been in performance and our ability to be able to incorporate large sets of feature layers, so that we're essentially reducing the limits on what you can show for points, lines, and polygons within a scene. I remember this was an issue with ArcGIS Online, and our users would get to that point with 1,000 features, and it's like a brick wall that they would stop and realize that this is something that they couldn't really use here. But in this case, we're looking at hundreds of thousands of points that are symbolized using smart mapping. This is a large set of lines, 20,000 features that are rendering here, showing the average daily traffic in a thematic way, really to get you to understand some of your existing typically two-dimensional data in a different kind of way, representing things like average daily trips here in Florida. And it's a large set of data. It's a feature layer that's not cached, and it's immediately being drawn upon. This is another example here from Florida. The state of Florida's GIO hosts all of the building footprints within an open data portal. And through simple extrusion, you can bring this in, start to build early aspects of a 3D state here in this case, and using some local government 3D base map solutions, which I'll get into a little bit later, you can actually use LiDAR to extract roof forms and make higher levels of detail. Another improvement around multiple levels of detail is with our 3D symbology for our web symbols. So this is what we'll see rendering here is a way in which we've improved the performance for this by having multiple LODs for those symbols. So out here at this level, you'll see a different level of detail, and if you look closely, you'll see these trees start to transform a little bit. It's something that's happening automatically, and we'll get even closer, and we'll have a bit of a different experience with how these trees actually render for us. And that's all in an effort to improve the performance and the scalability of what we're trying to approach. Loading and sharing a city full of trees is no easy feat, and here in this case, doing the same thing with a large-scale integrated mesh like from some of our partners that they provide or through Drone to Map is also a capability that you can do for a large area and make use of it in a variety of different ways. So we're going new places with WebGIS, and one of the biggest improvements here is actually using this in a mobile device. And so if you haven't had the chance to play with a scene a little bit on your iPhone or your Android device, give it a shot. It's really intuitive. A lot of our users are really excited about what this means for them, and especially for the first time experiencing zooming in and moving around and navigating your scene. It's a very native feeling right there for you. And it gets you to think a little bit more about what you can do in other places that you can go. So in this case, building scene layers. This is an example of bringing the Revit as a data source into a web scene, publishing it in a way that then enables you to work with it in a variety of different ways. So ArcGIS Pro, these are recent advancements that have been made recently to enable the publishing of these building scene layers. And you can go inside the buildings. You can use slice tools to break it out. You can use the Building Explorer to strip the different disciplines of the building, the walls off, and interact with these scenes so that you can highlight certain areas. You can work through the entire set of the building there and in great performance, and see that within the context of the web scenes that you're sharing here. I think it's pretty exciting as far as the potential of what can be done with this. And really, it's ultimately up to a lot of our users to start to imagine, what next steps they may take here with building scene layers. Some of the next places that we can go is actually underground. So we made some improvements here in 2018 around the ability to enable ground transparency so that you can view, say, utilities underground. You can look through the ground and see what happens to be, have negative Z values and be underground, or you can actually navigate underground as well. And here in this story map, that's the next step for this, is to get underground, enable that through a configuration function for the ground in the scene designer experience, so that you can then have the chance to be able to explore utilities or other features that may be underground. And in some cases, this is the life of some of our customers that work entirely underground. If it's either natural resources or utilities planning, they need this kind of context and understanding, where the placement, where collisions, where they may find additional context in terms of the 3D data that can be underground. Here's another example of underground seismic activity here shared within a scene. We're actually looking up from underground at, here in this case, this is well boreholes with seismic activity around it. A lot of possibilities once you can start to find new different places that you can explore with 3D WebGIS. And really this opens up entirely different industries in the way that you can work with 3D WebGIS. So a couple of different user experiences that's been introduced in 2018 and 2019 here is, this is the example of that Building Explorer tool that I was talking about before, where you're able to drill down through the various different disciplines of the way that the building scene layer is arranged, and take walls off, start to take a look directly at the HVAC system or some of the piping. This is a slice tool. It's both available in the JavaScript API and in the scene viewer experience itself, where you can exclude layers from slicing, or you can slice across the board for really any number of different features. Another additional feature that we've included here for 2018 is the filtering tool. In this example is the use of LiDAR here, filtering on a class code where we're separating vegetation from a wire transmission. Searching is now easy to be able to do. You can set up your feature layers to be able to search on a specific field for that feature layer and really get you the chance to, and give your users the chance to be able to navigate to specific points of interest and things that are of focus. There's a couple of apps too that actually utilize the value of what you can work with within a scene. And in this case, this is a scene with inset map example. This is a space-time cube where we're understanding the number of violent crimes that have occurred in Philadelphia. And this is a chance to really extrude time as a z-value and understand where there's groupings of statistically significant hotspots. And the inset map there in the bottom helps you to explore that with a web map. So you're seeing this 2D, 3D interaction that way. And the same way here, this is the compare app template. This is something that is worth trying. You can compare two scenes. You can compare a scene in a web map, or you can compare two web maps. And in this case, once we get to these individual slides here, we'll zoom to specific points of interest here within the scene, and that will then in turn navigate us to the web map equivalent to that area in order to understand slope around that area. So we've also worked towards recognizing that a lot of our users have a bit of a series of expectations with how they work with and they manage data. So one of the things, the add data dialog is now analogous to the web maps add data dialog. Very similar types of functions to be able to sort content or to search in specific regions and to ultimately find the data in your content or in ArcGIS Online or Living Atlas in a way that then enables you to start to work with it. And so finally, some of the other components here is the chance to be able to add your own style to how you're working with your web scenes. And so 2018 brought us a couple of things: solid edges, sketched edges, or the ability to take edges off entirely. The sketch edges are actually really pretty interesting to be able to draw focus to, say, proposals or other areas of focus, while the sketch kind of provides that backdrop for context for what's happening for the rest of the scene. And in this case, the ability to be able to style the scene background so that you can embed an entire globe, say in a publication, a blog, or a story map like this, and have that remove the stars and the rest of the atmosphere just to be able to focus on the data as it's being represented here within the globe. So it gives you a chance to be able to interact with this, but at the same time not distract from the rest of the application that you may be working with. And so working with that style, there's one more component here that I wanted to be able to bring about here is what the role that 3D solutions can play for the enablement and the creation of data and analytical product. And there's a couple of 3D solutions that I want to draw attention to here. This is advancements that have been made with the local government 3D base map, where you're actually able to use LiDAR data in order to generate roof forms that are truer than what you might have just through extruded footprints, which is really important for those that are just starting to explore how they understand the development of their smart city in 3D. And in a similar way, to be able to extract the floor plates or the floor volumes from those buildings, it helps to give a representation of real estate or land records or even vertical zoning. And one of the other solutions here in this case that helps users to really work through this procedural process where they're drawing their lines to represent power lines, having it run through a Pro's task-based workflow in order to generate procedural models for power lines in a variety of different ways. And so that here we're looking City of Austin, examples of the power lines that are rendering here for us, so that it gives you the opportunity not only to be able to visualize them, visualize a variety of different tower types, but then also conductor and tower structures that may differ from, say, rural environments and urban environments. But furthermore, there's an analytical component to this of actually generating what the potential sway of the line is, and how that vegetation may be encroaching in that specific area, and so that risk can be mitigated, and you could communicate those out to fieldwork crews in order to help to actually mitigate that risk here. So this is LiDAR data that's falling within that sway there. So these solutions, again, are very useful to get people started. There's standardized workflows that we've learned from a lot of our customers here in this case, and that we incorporate and make it a bit easier for you to adopt 3D or to provide 3D solutions for city, counties, utilities, businesses, a variety of your customers that are approaching some of this. Really just implementing some of these is a good way to get off the ground for understanding how you can start to work with 3D. Another example here in this case is the 3D flood impact solution. Thought these were important just to draw attention to here, something to take a look at. I believe 3D Solutions are going to have their own session here later this week. And I just wanted to point these out because they make beautiful scenes in their web scenes, and they're a beautiful way to be able to represent some common business problems that cities and businesses face on a regular basis. So this flood impact solution here is showing if water levels may rise to a certain level, then what is that impact? How greatly are some of these houses impacted here in this area, and visualizing that enables the way that we can communicate that as a problem. And we can also highlight and work with the authoritative data that's then created out of this in order to understand scenario planning and help to better mitigate the risk to life and property here in this case. All of these things, again, help to enable users quickly to work with 3D. Been working with visibility assessment, and this was a solution that was originally intended to develop line of sight and to quantify line of sight for things like real estate. And it also has another use case here of working within the public safety environment. And so in the case of being able to understand what's visible from the building and how do we pair that kind of information with things like the tactical operations solution, which ultimately helps you to decide, are evacuation routes in the right way? Are we placing patrol resources correctly? And do we have the context as far as what may be visible from where, who can see each other, and to really utilize that form of visibility assessment in a way that again helps you to communicate where potential risk may be, and to help ultimately better design plans and activities. Kind of coming back to the first point here, I wanted to show you another scene that's the example of the city of Rotterdam that's collected, and these are millions of LiDAR points, and the capability of being able to bring these and serve these over the web to then further either view them directly here throughout the course of a couple of slides through the scene viewer, or to actually bring them into web applications in order to further examine some of that data and to work with it more closely based off of what some of your business problems and the capabilities there. And we're at this point now where it's working with 3D on the web can lead to some really interesting and exciting opportunities. And so with that, I thought it was a good point to be able to show you just some of the recent advancements that we've made here. Again, just to reiterate on what Jim McKinney said this morning, we want to make sure that we're going the right path, and so this is a great opportunity for us to check in with you and to show you some of the things that we've been working on and where we're going, and we'd really love to hear more from you too.
All right. One factoid about Phil is he came on board. He's got a public safety background. He starts talking to some of the public safety teams. He talks to the Metropolitan PD in Boston on Friday. He sends me a travel request on Friday afternoon. Saturday, he flies out there, gives them a presentation. On Sunday, they were flying oblique imagery and then generating integrated mesh by Sunday afternoon so that he could support a World Series game this last fall on the next day. And the really bad thing is that not only is Phil not a baseball fan, he's not a Red Sox fan. So
it was my second game.
Yeah,
World Series.
That's right.
Good that way.
All right. So In addition to all the great stuff that Phil just showed, I just wanted to touch on, did you guys see this really fantastic young woman who presented on the JavaScript API, Raluca, this morning? So she is actually one of our best developers of examples and samples and demos out of that Zurich team in Switzerland. She also works on the core technology as well, but she is just a perfectionist, and she develops these incredible examples that she then posts up onto GitHub. If you search for Raluca and GitHub, you will probably find her up there. And what you can find then is these fantastic examples, such as the sketch app that she put together, this sketchy paperspace view of a city. This stuff is really incredible and just shows what some of the power of the JavaScript API is now in Esri with 3D. And I can't say enough about how much there is that you can do with the JavaScript API and our web apps in 3D these days. Even watching the story map that Phil put together, the diversity of what we've delivered is so much that I can't even keep track of it all. And I'm I was supposed to be the 3D product manager until recently. And it's just, there's so much stuff going on. We are always open for more ideas, however, and we're always looking to extend more. So if you play around with some of these things, you do some interesting things, and you want to send them to us, please do. Even a out-of-practice programmer like me, I took the JavaScript API last fall, and we built an Arduino. My son and I built an Arduino space station tracker, and then I was trying to figure out how to actually prove that it was accurate, and I realized, I could take the same API that I called from the Arduino and call it from the JavaScript API. And in like half an hour, we had an Arduino device, an IoT device connected to the web, talking to the space station service, and I had a web app that could show me that I was actually right, that the Arduino app was correct. And I was able to do that with a 12-year-old. You guys should be able to do a lot more than that, and likely he'll be able to do a lot more in the future too. All right. I'm going to just touch on some brief roadmap stuff, and then we'll save a few minutes for questions. Like I said, there's so much coming that I can't capture it all on one slide or talk about it in one whole slide deck. If I look through some of the things that have been delivered in the last few months, we've got the building scene layer. The slicing tool is now there on the web. Last year when we demoed the slicing tool here in Pro, the #1 request was, can you please move that into the web? And so now it's in the web. We've delivered multi-LOD symbols. Does anybody know what 3D empirical Bayesian kriging is? Okay, one, two, three. All right, couple, 4 people. So 3D EBK is an interpolation method so that you can take a bunch of scattered points in 3D space and actually interpolate what the value of space between them should be. We actually released a workflow to make this happen. You can get up to about 300 million points, which will process actually I think it's up to about 1 billion points. They'll process in about 12 or 24 hours, but you can do 300 million points a lot sooner than that. And then we have a workflow for visualizing that interpolated space as slices. You can then take the slices, and I think you can actually move them into some of the raster tools for analysis. And then one of the things that we're going to do in the future is hook that up with the voxel scene layer, which is probably coming at the end of this year. The team actually I discovered by accident, the team that had built the 2D standard deviation ellipse tool actually made it work in 3D. So you can actually have these 3D standard deviation ellipses now if you work with like oceanographic or subsurface content. It's pretty cool. Useful actually, not cool. We've got improvements in Earth around KML and some of the other workflow there. Point clouds are now in runtime, I think, in the 100.5. Phil's got a 2D, 3D template that he'll talk about sometimes. We've got this new utility line solution, flood solution. There's a big update to the i3S spec. I mean, there's so much stuff going on. It's kind of useless to list it all out, but these are just some of the high points. In the near term, we're releasing ArcGIS Urban this summer. We're looking at, for those of you who know what GLTF is, we're actually working on a GLTF upload workflow, which actually Raluca kind of accidentally showed in that. There's a lot more intended to be in that upload workflow in the long run. Pro is actually getting better lighting and water effects. And if you go to the Pro roadmap ahead, I think that the road ahead they'll show you what that actually looks like. It looks dramatically improved, let's say. Cut and fill tools are coming in Pro, so more interactive tools in the platform. Profile viewing, Earth is going to mobile. We've got this voxel desktop user experience for the end of the year. Mobile scene packages I already talked about a little bit. We're working on a global coordinate system for the Chinese market that also is useful for some other markets. And then in the longer term, we're actually looking at releasing a plugin for Revit to actually allow an architect to georeference a building and then export it for use in Esri. There is a legit use case for why some architects are required to do that. Usually they participate in larger BIM processes, or they're in green building energy conservation type workflows that they're working in. We are planning to take the voxels and move them to the web. We're looking at a transportation scene layer. There's a lot more interactive tools that are planned. We definitely have plans for integration with IoT. And for those of you who picked up on the acquisition of the Indoor.rs company, that's part of the ArcGIS Indoors product, the long-term plan, hopefully not too long-term, with that Indoors tech, which is a indoor positioning system, SDK, basically. The goal is to move it into the platform. So you could take one of these great 3D experiences that Phil is showing you out on a mobile device and actually use the Indoors tech in some way to actually have the blue dot for your location in that experience. I mean, so there's so much coming along on 3D these days that it really is proving out my original thesis that it's just GIS, and we're seeing it everywhere, and hopefully it's helping you guys and helping you do your jobs and improve the work output that you can actually generate. So, all right, we have about 5 minutes that we can take a couple more questions. Thank you all for your participation today. Are there any questions? Yes, sir, I saw your hand first.
Yeah, about your BIM integration, is there anybody I can talk to with you said AECOM and HDR here, and they're using them. Are they within Esri person talking about that?
I said some of them are here. I didn't make any commitments about who's using it. There are some that are using it. Yeah. So okay, is there anybody that you can talk to about like implementation or?
Yeah.
On the customer side, I'm not sure right now who would be here who might have done it, but myself and Don Kinney is another product manager who work on this. We can talk to you about it. We have a talk on Friday, but
what station are you guys at?
I'm pulled in many different directions. So if you wanna give me a business card, I can try to text you and try to find a time when we can talk. And there was another hand that went up right here.
How much we're showing these 3D representations over the web? How much is that dependent on the user's machine as far as performance, or is that done on the server and passed back, or something else?
So it's browser based, right? So if you're on Internet Explorer, these aren't going to work. If you're on Chrome, they should work. Chrome can eat up to a couple gigs of cache space, I think. So if you're on an older machine that can't support that, then you might have a worse experience. Bandwidth will also control some of that experience too. So if you're on home or hotel Wi-Fi or convention center Wi-Fi, it's not going to be as fast as being in a higher performance Wi-Fi or networked connected environment.
So a better GPU on the user's machine is going to make it perform better. Is that fair to say?
Yeah. You know what? How much, Gert? Do you know how much the GPU actually affects the WebGL? Yeah. It does. Yeah. Okay. All right. Yeah.
And just to add to it, to the mobile experience or working within a scene on a mobile device, it's iPhone 8 and up, and then some of the more recent Androids formally.
Right. Yeah.
But you can still worth trying.
And that was because of GPU access on the mobile devices. So that's right. Yeah. Another question, certainly.
There's a lot of 2D open data out there.
Yeah.
One of the stuff I'm interested in is this i3.7 spec.
i3S, yeah.
Yeah, or i3S spec. Are you thinking this is something you can kind of see things move into open data, kind of community-based, like, parks and recs and just general
Sure.
features that you can kind of...
Sure. Okay, good question. So, and I forgot to repeat some of the questions. So the question is, there's a lot of open data out there, but a lot of it's 2D. We have this i3S spec. Do I see a lot more 3D open data emerging? Yes and no. Like OpenStreetMaps, for example, actually has 3D content, and not just extruded buildings. If you look at their OSM viewer for Chicago, you'll see correctly shaped skyscrapers and things like that. There are already some efforts to do 3D data in the open community. Some of the problem is it depends on what your problem set is. So like for trees, I don't see that happening other than outside a city or a county or something like that. To some extent, I'll just say it depends. We have some plans around, say, a simple 3D building shell layer for the world. I can see infrastructure happening at some point because it's a really high demand area where we might actually have to provide like clover leaves and things like that. Yeah. I would say it's been a little early to do that, but we definitely get different pinpoint asks around it. So I3S, just so everybody's clear, I3S is actually an open specification for sharing content. Open data is the actual like licensing and the act of actually taking your data and pushing it out there in whatever format. You definitely can serve out I3S as open data for sure, and as proprietary content. One more question maybe. Sure, Cameron, what's going on?
The ArcGIS API content, does that involve rendering impression improvements?
I don't know. So it involves a whole bunch of improvements. Some should impact rendering, but like I know some of the data coming from like context capture in some of your parts of the world and stuff, some of it is not being fixed in the spec because some of it is a problem in some of the source. I'm supposed to be writing the blog on it. I have it half completed, and I should have that out maybe later this week. Maybe later. I know we're chatting later. Maybe ask me. I'll tell you. I'll take one more question if there is one. Yes, sir.
For integration with Autodesk, do you have any plan to write the data back to Revit?
So great question. So for integration with Autodesk, do we have any plans to write the data back to Revit? Boy, there are like 15 different patterns of how we could do that. Right now, we're reading it. The next step is to actually allow you to kind of have a live data store underneath that scene layer cache so that you could actually update it. And then from there, it might be possible to write back into Revit data, right? The big problem, though, for big BIM programs, for example, is that the way that data are versioned in GIS is fundamentally different from the way that it's versioned in the BIM program. If that data is live being used in construction processes, then I guarantee you no engineer is going to want to stamp data that's been updated back through GIS. So, there are all other considerations to the workflow that need to be taken into account. If it's purely an O&M, scan to BIM, post-construction workflow, then I think that's where we'll start to see bidirectional flow of information a bit more. But during the design and construction period, every one of those submitted documents is actually a legal record. And so it's not necessarily even desirable to have the GIS directly updating the BIM. It just depends on the workflow and the use case. But that's a really common question that I get. Another related question around that is, what's the common data environment between GIS and BIM? And my answer is, well, it's GIS and BIM repositories. There isn't a single common data repository that we're ever likely to have between GIS and BIM. Maybe in 100 years when some AI figures out the perfect way to do everything, right? But today we have engineers working in MicroStation, CATIA, Civil 3D, Inventor, things like that. We have architects working in Revit, ArchiCAD, other things. And then we have GIS users working in a variety of ArcGIS flavors. Matching those all up in one, and many workflows around it, into one common data environment is, like I said, the common data environment is the GIS stack and the BIM data repositories, whatever those are, with spreadsheets and schedules and CSVs and all kinds of stuff. So it's a complicated problem set, but we do know that it's important. I think for some use cases, what we're doing with the data store underneath the scene layer in the next couple releases should actually allow you to start to think about how you could actually update the BIM record data from GIS. Right now, that's a little bit in front of where we are, but good question. All right, thank you all very much for sticking out this whole time. Nice to see you.